Hi all. In the previous session, we understood what is a class and what is an object, and we have seen how to create the class and how to create the object. What happens if I create an object? All the things we have discussed. In this session, we are going to see what are the different types of data members, different types of methods available. So let's try to understand. Before trying to understand different types of data members and methods, so quickly I'll recap what we understood in previous session. So we know that class is a it's a template or it's a model to create an object, or we can say class is a collection of data members and methods. So let me write a simple class here. Let's take an example. Suppose addition program I'm just writing. So if I take any variables here, I am taking just three variables here, and we know how to create the method. I mean, previous session. However, we'll see this also. So this is just one sum method I am taking. This is not returning anything. That is the reason that return type is a void I have taken. And just assign the values to these variables: a equal to 10, b equal to 20, and you can just hold this a plus b into t. So we'll just print this. Sum is if you want to just use this as a variable, just you have to use that plus operator, concatenate operators t. So this way we have created class, right? So method I have closed and class also I have closed here. So we know that if you write a class, I mean for class there is no memory space is required, but if you create an object, memory space is required, right? Let me take okay, this is a execution logic class. So how we can create the business logic class? Nothing but main method. So just I'll write one business logic class. Class name is just program addition, and we know that public static void main we have to use. So JVM will look into the main method as discussed earlier, and we will take one main method here. So just create an object for which class we are creating. Add, right? Just create an object. We know how to create an object. Add is a class name, and you can take any object name, just variable obj I'm taking, and we know how to create by using new operator. So new operator, and we can add that constructor. Okay, constructor we'll see later. So how to call this method? This is some method, right? With respect to object obj dot sum. So what happens if I create here like this? So first, as I discussed, when you execute this program, class loader subsystem, that is one program that first, I mean, before that class loader subsystem, first you have to compile this program. Whenever you compile this program, by how to compile? By using Java C, and program name. Suppose if I save this program as a m.add. So first you can compile this. If you compile this, what will happen? Java compiler will generate one dot class file. Let us say m.dot class file. So this we are saying as a bytecode. So bytecode is nothing but a set of optimized instruction generated by the Java compiler. It is an unreadable format. Already we have seen this. Now, once this class file is there, what will happen? How to execute this program? By using Java and program name like class name. Okay, program name. I am saving it the madd. Whenever you execute this program like this, what will happen? First, class loader subsystem. It will take this class file from the secondary memory, from the drive wherever it is available, and place it into the main memory. We into the RAM. Okay, what will happen? And once it is available in the main memory RAM, JVM will pick this file, and it looks into the main method where it is available. So it will find the main method. After that, program starts from the main method. This is how it happens, right? So when it starts it, what happens? Object we have created. Whenever object is created, what will happen? We are using new operator, right? What new operator will do? New keyword will do. So this one, it will create the object for you, right? What is the object name? Obj. Obj creates. For which one? For which class? Add. It will go to add. In add, how many variables available? A, B, T, right? So what new keyword will do or operator will do? It will allocate sufficient amount of the memory space for the class. What is the class here? A. What is the int type? The data type is int, right? It occupies 4 bytes as discussed. Like this for B. For T. Like this, it will allocate the memory. After that, what happened? Object.sum. Next control goes to come here. Object.sum. Where it object sum method is available in this class. A equal to 10. It will place 10. Next, B equal to 20. It will place 20. So A plus B, 30 it will save. When you print system.out.println, so this program, it will give the sum is 30. Output is a 30. This is how program will execute, right? Now, try to understand here one more concept here, that is a heap memory and stack memory. Okay, let me take one example here. So in this session, we're going to see what is a stack memory and what is a heap memory. So how Java program will allocate the memory in the main program. I mean the main memory, RAM, we will observe here. As we are aware of that, we know this. Okay, let me go to from the scratch. Like we have memories available, right? In the main memory, we have how many memories available? Main memory, secondary memory, and heap memory. So under main memory, what and all comes? We have RAM, ROM, right? Random access memory and read-only memory. In the secondary memory, we have CD, DVD, hard disk. Hard disk again, it will SSD, SDD, and we have heap memory L1, L2, L3. Cache memory, sorry, not heap, cache memory. So we have different types of memories available in the machine, right, system. So we know that RAM is a volatile. Volatile is nothing but when power is switched off, your data will be erased. This is a non-volatile. When power is switched off, your data won't be available. Will not be erased from the ROM. However, whenever memory create where Java is creating the memory here, the RAM. Okay, so in the main memory, or we can say in the main memory. In the main memory, again, it will create some subtypes like we have stack and heap memory. Stack memory and heap memory. What is this stack and heap memory and how memory is allocating when you start your programming? We'll try to understand here. So let me, before seeing the example, stack memory is a one memory where what data is available here? Primitive variable, primitive type of variable and reference variable, it will allocate. So memory will be allocated for primitive variable and reference variable. Heap memory is nothing but objects will store into the heap memory. Let's consider these are the some objects. So what stack memory contains? Stack memory contains primitive variable data and reference variable. Heap memory, objects data, it will store that. We'll try to understand how it will allocate when you start your program. Okay, now let me take one sheet here. So let me write sample program so that we'll try to understand what happens. So don't worry about this public, modifiers, access modifiers, public, private. Later we'll discuss all the things. Just assume that I have one class here, public class. Let me take on sample class. Okay. So public static void main string args. We'll see what is the string args later. Just we're considering one main method I have. In the main method, I have 10 method and method one we can, let's say method one. Okay, that's fine. Now I have public void one main, not main, just let us take one, consider this is a method one. I have one method one. So in method one I have within the method I have some local variables, a equal to, let's take some, okay, A already I had defined, right? Let me take B 20 and C 30. Okay, so this is a one method. I have one more method, public void method 2. So let me take one local variable like int d equal to 40. Okay, so in the class, I have main method. I have two methods, okay, two user defined methods. So here what happens is, as we know that JVM looks for main method, right? When program starts executing, one thread will start. Okay. For each and every thread, one stack memory will be created. Okay. How it will create it? I mean, memory allocation will happen internally. So we know that control comes from main method first. So immediately when comes to control comes to this main method. Suppose thread started, right? Thread currently now in the main method. So what happens? Immediately one stack trace has created. How it will create it? This is, we can say, stack frame also. So for main method, immediately some memory will be allocated for here. And what and all available in the main method? Suppose int a equal to 10, right? So that where data is storing here. And also this is the main method. So this is how memory will be allocated in the, this we are saying as stack, thread stack, or stack we can say. And next control comes to method, next method, right? Method one, we are saying method one. When control comes to here, immediately stack frame will be created for method one. Let us assume this is a method one. For this, what and all variable available, b equal to 20 and c, right? bc, for b and c memory will be allocated. And immediately how it will go? So method 2 what and all available? Method 2 we have b 20 30, right? So similarly method 2, only one variable I have, d. Okay, d is variable like this. So whenever thread starts, for each and every thread one stack memory will be created. So inside this, based on your thread, right? Suppose control comes to here, immediately for this method some memory will be allocated in the stack area. Similarly after this, one more method like this. So what about heap memory? Let's try to understand heap memory. Stack memory, we understood all these different primitive data type of variables, it will store it here, right? So what about heap memory? Suppose let's me take one small another class. Let's assume I have some XYZ class I have. So int AB. So let me take one method here. Okay, this is a separate class. Okay, separate class I have. So I let us consider one more method, public void method 3 I am writing. So in the method 3, what I am doing is I am creating one object, okay, for this class, for XYZ class. So how to create the object? XYZ. Suppose X is my object name. New XYZ constructor. So what happens when I create here? So whenever you create an object, that it will create in the heap memory. Objects are stored into the heap memory. So what is it? XYZ, right? XYZ. So one object will be created. What and all variable here available? XYZ class int AB, right? For AB, memory will be allocated. So whenever it creates here, immediately in the stack trace, one variable like this reference, it will be stored into the stack. What is the next control comes to here? Method 3. What happens? Method 3. As I said, method 3, it will be created. Method 3 and reference will be created here. Which reference? What and all available for in the heap memory. So it will, by using this reference, it will access this data. This is how heap memory will be created. So whenever, suppose control, third one is executed, right? It is done. Then this memory will be deleted from the stack. And after that, next, whatever previously completed, right? Method 2, it will be completed, erased from the memory, like this main method. Again, it will control goes to, that thread control goes to main method, wherever it started, it will go. And once that is done, program execution is done, this will also will be deleted. And here, when it will be deleted, when third program, see third method it is calling, right? When third method it is completed, automatically this memory also it is deleting. Or else we can say what happens is this is not referencing because method 3 is already completed, right? What will happen is one garbage collector, it's a one thread. As discussed earlier, it is a garbage, it is a one background thread it will run, right? So it will check this object is used by any thread or not. So if it is not used by any thread, so this thread garbage collector, it will remove this space and it will give this space to any available to the next thread. So this is how a garbage collector works also here in the heap memory. So the overall what we need to understand here is, so this is how memory allocates in the internally in the main memory. So based on this method, right, data types, whatever method contains local variables, all the things available, it will be created in the stack area or stack frame, we can say. And heap is nothing but what it stores objects. Whenever you create an object, that data it will be stored into the heap memory. So this is about stack and this is about the heap. So for each and every thread, separate track. Suppose this is a thread 1. Again, your programming is running. So separate thread, that is a thread 2. So for that separately stack memory will be created. Stack this thread 2 stack memory will be created. So heap memory is a common area. So if you required here any data, it will point to that reference, or in the thread 2 it will point taking that reference like this. So this is how memory allocated in the main memory. And also we understood that what is a stack and what is a heap memory and how it allocates. Who will allocate all these things? JVM. JVM will allocate this method, this memory in the main memory. Okay, this is a one concept. And next one, as we discussed, we will see what are the different types of data members and what are the different types of methods. So we have discussed earlier, class contains data members and methods, right? Or we can say variables. Data members or variables or attributes or are synonyms. Okay, any name. Okay, class contains data members, I'm saying, and methods, right? So what are the different types of data members available? What are the different types of methods available? Let's understand this now. So let me take here, let me write simply class data members and methods. So data members, we have two types of data members. That is, one is instance data members, we can say. One is static data members. Data members is nothing but variable. Instance variables, static variables, static data members. So this is an, we can say, non-static also. Non-static data member. So we have two types of data members. One is instance data members, one is static data members. Similarly, we have two types of methods. Instance methods and static methods. We can say this instance are non-static method also. So let's try to understand first data members. Okay, what are the instance data members and what is a static data members? Data members is nothing but what? We know that suppose if I create class into a string s, all these are the data members, right? Variables, right? So we have two types of variables here. One is instance variable and one is a static variable. So let's try to understand when do we need to, first of all, what is the instance data members and what is the static data members? Let's try to understand here. If you want to uh, do some specific values, suppose if you want to store specific values, let me take any example. Let suppose if you want to store student number, okay, student number equal to 10. And if you want to store name, if I consider name as a string data type, string name equal to your student name. Let us take any name. Okay, student name. Let us take. Okay, so these are the specific values, right? Because it can vary, right? I mean, student to student, it can vary. But if you want to store the common values are nothing but what? Common values are nothing but suppose if you take any, let me take one university. University name is common, right? University equal to Apex, suppose. So university name is common, but these are the specific values. It is vary from student to student. So these are the common specific values. Sorry, specific values we can consider. If you consider these are the specific values, if you want to store the specific values, then we can use the instance variables. Okay, if you want to store the common values, this is common for everyone, then we can use the static variables or static data members, we can say. So let's try to understand what is a common here. I'm saying common, right? Okay, let us take simple example so that we'll try to understand here. Let us take one student class. I'm just taking one student class. Int roll number, suppose that number, and string name, student name, and the string college. Let me take our university or college. College name is something. ABC is a college name. Okay. So if you see here, these are the instance data members. Already we are saying instance data members or instance variables because these are the not non-static. We'll see, I mean, how to create the static. First, we'll try to understand if you declare like this, these are the instance variables or instance data members, right? Suppose you have 100 students in your college. If you can create the object for each and every time, memory will be created, right? Suppose first time, how to create the object. Student is a class name. Student S0. First object I am creating, and new operator and student. If I create like this, what happens? Memory will be allocated, right? For whom? For roll number, for name, ABC. One object will be created in the object roll number. Roll number one, let me take whatever I mean objects you can provide. Roll number, name, and what? College. So this entire one object. If I create another object, student S1, again memory will be created for all the these things, right? All the instance data members, right? Because these are the instance data members. So instance data members are nothing but always whenever you create an object, memory will be created. Again, roll number, name, college. Here, if you observe, see, like this 100 objects, if I create 100 times all these for these instance data members, memory is creating. If you observe here carefully, college is common for every student. So is it required to create every time memory for this college? Because college is same for 100 students, right? So this is a common. So this is a common for all the students. Then this kind of common data, if you want to store, then you can use the static data member. So this is how we can consider, okay, we have to go with a static data member to store the common values. I hope you understand this. So let's take this one. So we understand that, or let me write it here, non-static data member. Okay, this is a static data member. So non-static data member, when we need to go for non-static data member, if it is a specific values, then we can go to, you go and use the non-static data member. If it is a common value, you can go and create the static data member. How to create that first of all? How can I create? I am saying int, suppose student number equal to something. This is a non-static or instance, we can say. Instance we are saying, right? This is fine. How to create the static data member? By using static keyword. Just you can create static. This is a keyword, reserved keyword, static. Suppose college, right? I'm saying college equal to ABC. ABC, college name is ABC. So this is a common. That is the reason I'm creating static. What will happen if I create the static? Memory will be created for only once. Okay, go to the previous example only. What happens? Okay, let me take here only. What happens if you create the common like this? Whenever, I mean, you create the objects 100 times, right? One area college will be created like college ABC. So if you create an object, first object. it will refer this one. Second object, it will refer like this. Third object, it will refer like this. Remaining common values, it will be stored like this. Suppose roll number, name, roll number, name. But college name, it is picking from this object or this data member, we can say. So this data member, it will refer this, like this. So what is a static? If you create a static variable, memory will be created only for once. Okay, if you create instance variable, memory will be created each and every time whenever you create an object. This is the concept of instance and static data member. So we understood here how to access this one then. So if suppose I created like this is the instance data member, right? How can I access this instance data member? Instance data member, always we can refer with the object name. So we have to, let me take, right, syntax, object name dot instance data member. So it is related to object, right? So you have to call the object name dot, what is this? Student number. So object name, suppose I have, let me take object is my object name, student number, like this. If you call this, then this value you are able to access this value. How to call the static data members? Static data members, we have to call with the class name. What is the class name here? Student, in a previous example, student, right? Class name is student dot, what is the data member? College. If you call like this with the class name, then you will be able to access this static data member value. And then what is a memory space is created? We know that memory space is created each and every time whenever you create an object. This static data member memory creation only once, whenever it's loaded into the main memory, only one time it will be allocated. This is about the instance data members or non-static data members we call, and static data members. And another one is, already we have observed final keyword earlier, right? Final is nothing but constant values. If you want to store final, we used to store it, right? I mean, as I said. So let me take a simple example. Suppose pi value is common. Let us assume pi value is common, right? 3.11417F. So this is a constant value. So throughout your program, you don't need to change this value because this is the constant value. Pi value is, this is a constant. So in this case, what we need to do earlier, as I said, we can have final keyword for this value for this data member. So if you make it as a final, you no need to change this. I mean, you can't change this value during your execution, program execution, right? So whenever it is final, you can use the static one. Why? Because let's try to understand what is the difference between static and final here. So static deals with the memory management. Whenever you create any static data member, what's the purpose of static? Memory will be created only once. What is a final? This is dealing with the constants, like you can't change that value during the program. So if it is, I mean, if you don't want to change this value, your program, make it static, this one, because this value is same. I mean, you can, I mean, fixed one. So in that case, if you make it static, it will be created only once, memory, right? Memory will be created only for once. That is the reason always whatever final values you have, you make it as a static. This is a one point. And other vice versa. Suppose I have a static data member right here. See, let us take this example. Static college. Here static. Can we make all static variables as a final? No, because static is, I mean, static, this is a college, let's take. Tomorrow college name may be changed BCD, some other name. So static may or may not be final, but all final data members are static. This is also very important to understand this. And this is about the instance data members and static data members. And similarly, we will see what is a instance methods and what is a static methods. Let us try to understand in similar way instance methods and static methods, or we can say non-static methods or static methods. We have two types of methods we are saying, right? Instance and static. Let's see when we can use the instance. If you want to perform some specific operations, what is specific operations? Let me write specific operation. Or we can say what how we can, what are the operations are specific? We can say repeated operations. So what are the repeated operations? Let us take any example. Suppose if I want to read the data from the file, I want to read data from file, or instead of file, maybe database I have file or database or any file. So if you want to read this data, it's a repeated operation, right? Suppose you want to open that file and all the lines line by line it will read and save it into somewhere else like this. So these kind of repeated operations or specific operations, we can go for the instance methods. When we can make static methods, so if you want to perform one-time operations, what kind of operations we have one time? Like if I take any example, so open the file. See, open a file. If you want to read data from the file, just you need to open the file one time. After that, line by line, you can read it. So one time you are opening the file, or we can say database connection. So if you want to perform any operations in the database connection only one time you can connect. After that, whatever you want to do, you can do that by operations. And like this user authentication process. So one time authentication is required. So that kind of operations or logic, we can save it into the static methods. You can create the static method and save it. Okay, write it. If you want to repeated operations or common operations, then that time you can go for the instance, like non-static methods, we can say. So how to create the instance methods and how to create the static method. As we are aware of that, how to create the method, first of all, syntax, return type we should mention, and method name, and parameters if required any. This parameters concept we'll see later. Just this is a syntax. Return type we have to provide, method name, if parameters we need to provide, this is a logic we have to write it. And similarly, just use the static keyword in front of that method. So return type, suppose return type, method name, parameters if any. So use the static keyword before this return type, so that that method we are calling as a static methods. So when we can use that, we have discussed. And how to access this? If I have instance method, how can I call with respect to object name, right? So object, suppose obj is my object. What's the method name? Suppose method name is my method name. So like this. So if you call with object dot method name, so you will be able to access this method operations all. And how to call this static methods, how to access this with respect to class name. Suppose student is my class name. Student dot, what is the method name here? Let me take method 2. Method 2. So this is how we can access this by using object name. If it is an instance, if it is a static method, you have to use the class name. By using class name, you can access the method. So that is the reason we are calling instance methods are nothing but object level methods, because this is dependent on object. Static methods. What are the static methods? Static methods are we can call as a class level methods, because it is dependent on the class. So this is about the instance method and static method. So we try to see that complete class now. Let me take class structure, I can say. So if I write any class like this, so as discussed, what and all class contains data members and methods, right? What are the data members available? What type of data members available? We have instance data members or non-static, we can say, and static data members. Similarly, what type of methods we have? Instance methods and static methods, right? Static methods. How to call instance data members? By using object, right? How to call instance methods? By using object. How to call static data member? By using class name. Similarly, how to call static methods? By using class name. So this is a complete, okay, this is a different types of data members and methods. So if I write complete class structure now, so let us take one class structure, package details first. What are the packages? Later we'll see. Package is nothing but a collection of classes like classes, interfaces, sub packages, all the things. This package concept we'll see. First package will come, and after that class. Class is a result keyword to create the class. Class name is a user defined. You can give any user defined, and data members. Data members and methods, user defined methods. And after that, so this is the main method we have. Public static void main. We can give block of statements, whatever program you want to export it. So here we have what type of data members I can say. Instance data members it may have, and it may have static data members. It depends on your requirement. It may have instance data methods and uh, static methods. So this is a complete structure of class. Okay. Now we'll try to understand few rules here. Okay, whatever we have discussed till now, right, in theoretical part. Suppose instance data members, static data members, and instance methods, static methods. How to call this? What are the rules? We'll see now. So let me go to first rule one. What I am saying is here. Suppose, uh, okay, let me take static to static. Okay, data members, however, we have seen. For methods, we'll see now. So if it is a method is static and calling method is also static, then how to call this? And rule number two, if it is an instance method, you want to call instance, how we can call it? If it is a if it is a static, suppose you want to call the instance. If it is instance, you want to call the static method. Okay, this one we can try to understand now. So here try to understand some rules here. If it is a static to static, your method is static, you want to call the static method, then you can call directly if the both methods are in the class level. If it is a separate classes, let's see later after inheritance concept. For time being, you can understand static method to static method directly you can call. Instance method to instance method directly you can call. If it is a static method, you want to call instance method. If you want to call instance method, then how to call instance method? We know that instance method, this one, right? Instance method call from the with respect to object name. So we have to use object name. Based on this, you can call this instance method. How to call from instance method to static method? If you want to call static method, how do you call static method? We know that this is with respect to class name. In this way, we can conclude that if you want to call static method from the static method, directly you can call if it is both are in the same class. If it is an instance method, directly you can call. Even, I mean, not only this one, you can use class name also. Okay, we'll see. I mean, we'll see how these. So try to understand these four scenarios here. So let me take one simple example. Try to understand this concept. Let me take one simple class here. See, I'm taking one class here. Okay, main class. What I have taken? Void f1. This is a one method I have taken. This is a which method? Is it static or non-static? Non-static. That means instance method, right? Because static keyword is not there. So this is an instance method. Okay, fine. From the F1 method, I'm calling F3 method. Where is the F3 method? Here. F3 is what? Instance, right? So this is an instance method. I'm calling from instance method only. Directly I'm calling because this is a same class. Like this is an instance method. This is an instance method. That is the reason I'm directly calling. This is a fine. And the second one is, if you see here, okay, see here, this is a which method? This is an instance method. I'm calling F2 method. F2 method is what? Static method. So if you want to call the static method with respect to class name, what is the class name? Main class. That is the reason main class dot F2 I'm calling, because this is a static. This is a one rule. And what about this one? If you see here, main method. Main method is a static, right? Main method is a static. How to call the static to static? If you see here, I'm saying this is a static method. What I'm doing here, F1 I'm calling. What is the F1? F1 is a instance. Method, how can I call? With respect to object. That is the reason I have created an object for this class, and this is object name MC dot F1. So object name dot uh, instance method. How to call main class? See here, main class dot F2 means what? What is a F2? F2 is a static. How to call static method with respect to class name? What is this class name? Main class is my class name. That is the reason I am calling F2. These are the rules, you can remember this. So let us save this. Just quickly run this. So okay, let me clear this, or else let me take this simple one more command prompt to just understand. I'm just taking command prompt. How to compile this? What is the main class name? Main class dot Java, right? See, I just compiled. How to execute it? Just by using Java and class name. See what will happen here? We'll try to understand quickly. So main class, right? See here, control where it will go. First, it will go to main method, right? Okay, control goes to main method first. After that, I am from the main starting. So printing, I am from the main starting. After that, where it control goes to fc dot mc dot f1. Where is f1? F1 here. It will control goes to here, F1. So what we are calling F3. F3 I am calling. Go to F3. F3 what I am calling F2. F2, where is F2? Go to F2. So F2 is a static. It is printing F2 here. Correct. After that, what it has to print? After that, F3. See, F2 is printed. After that, system I'm just again printing F3 instance. So F3 is instance printed. After that, F3 control goes to here, right? So F3, after completing F3, what will happen? F1 instance, it is printed. So finally, after finishing this, mc.f1, again a control goes to here. Main.class F2. Main.class F2 is nothing but what is F2? What print statement it contains? F2 static. So this is a F2 static. After that, control goes to final. I am from the main ending. I am from the main ending. This is how it worked. Now, and try to understand another one more concept like system.out.println. What is the system.out.println? Try to understand here. So we are writing every time system.out.println, right? What is the system.out.println? Let me write here. Print or println. Two methods we are using, right? If you write println, control, it will show in the line by line. Okay, if you write print, all the statements, it will show in the one line only. So this is a two methods we are writing. So what about this? Try to understand. Print and println methods. These are the methods, right? These are the two methods. Two instance methods are nothing but non-static method. Okay, instance method. So how to call instance methods? instance methods we have to call with respect to object name, right? Object name. We have to call with the object name. So these are the two methods available in the print stream class. This is one class available. Under this class, print and println methods are available. So if you want to call these methods, how to call? These are the instance methods. So instance methods calling from the print stream class. We have to create the object for print stream class. Okay, we have to create the object for print stream class. Where this print stream class object is nothing but a out. So this in programming language developers, we can say, whenever the Java develops, right, those programmers, what they have done is they have created print stream uh, object is out. This is present in the one static data member in the system class. So static object. Okay, out, sorry, out. So how to call this static one? Static data member. This is a static data member. Okay, so that is the reason static data member how to call system, right? Class name, right? With respect to class name, system dot out dot println, these methods, print or println. This is a concept of system dot out dot println. So this is a session for today. We understood what are the stack and memory, heap memory allocations, memory management, how it works when you write or execute a program while executing the program. And also we have seen what are the instance data members and static data members and instance methods and static methods. So that's it for today's session. Thank you all.